Okay, we have data, and we're going to use it to find how certain events are connected. So we have a bunch of students, and we noted whether they're male or female and how they get to school. Do they bus, do they car, do they bike or skateboard or whatever, and then we have grand totals. So there's missing numbers in here which we need to fill in first. Just for the guys, 350, 550, there are 625 males in the study. 300, 475, there are 575 girls in the study, for a grand total of 1,200 students. And if we add this way, bus riders, there are 350 plus 300 is 650. Car drivers or passengers, there are 375. And other, there's 175. And if we add in this direction, 725, 1125, what just happened? No, 725, 1025. I'm just making sure they add up to 1200 in this direction as well, and they did once I got my algebra straight. So, complete the totals in the chart. Done. How many students attend the high school? 1,200. What is the probability that a student is male, first of all? If you just have 1,200 students and you randomly pick one, what's the chance that you have a male? It would be 625 out of 1,200. You can reduce that with a little bit of work to 25 out of 48. And it won't reduce any further than that. I don't know if I want to reduce all of these because some dividing by factoring 1,200 is not going to go well for me consistently. So I may just stop them here and leave the reduction to you. Okay, probability. What does this mean? Probability that a student rides a car given that they're male. So in this case, we're looking at ignore the female and total rows. We're just looking at males for now. What is the chance that just in this group we have a car rider? So given that it's a male, there's 625 of them, of which 200 are males. If you reduce that, you get 8 out of 40, 8 out of 25 actually, just under a third. So that's the probability of that a student is a car rider given that they're male. And now we can go the other way. What if we grab a student who rides a car? What's the chance that they're male? So now it's given that they're a car rider, what's the chance that they're male? How many car riders are there? 375. Of which 200 are males. So the chance will be 200 out of 375 that you've picked a male if you just pull a random student out of a car. Divide that by 25 and you get 8 out of 15. And finally, what's the probability that a student is male and takes a car to school? Here's the wrong way to do this. The probability of male times probability they're a car rider. You just find the probabilities of each of these and multiply them together. That does not work because these are not independent events, and the multiply them together idea only works if the two events are totally independent. These events are dependent because we've noticed that it seems the chance that someone takes their car to school is somewhat related to gender. These choices are not identical on gender lines, and so it isn't safe to say that being male and taking car to school have nothing to do with each other. So the way you do this when you know the events are dependent is the probability of M and C. This is your multiplication for dependent events, is we'll say the probability that a student is male times the probability that they're a car rider given that they're male. And good news, we have this already. We found it in part II. So if you want a student to be male and a car rider, you go, okay, first let's get all the males. There are 625 of them out of 1,200 kids. And then, if you know that a student is male, there's an 8 out of 25 chance that they take a car to school, either driving or passenger. And now you simplify this. I'm just going to multiply it out, and I'll leave the reduction of the fraction to you. That should be 4,800, 5,000 over, oh dear, 2.5, 3, 30,000. Oh, it's not bad, 1 in 6. And we can actually check this. This is saying 1 student out of 6 at the entire school is a male who takes a car to school. There's 1,200 students in the school. Multiply that by 1/6, and you get there should be 200 students in this school who are male and take a car to school, and lo and behold, here they are. There are indeed 200 students who fit that description. They're in the male row and they're in the car column, so this calculation worked. So remember, we can't just do male times car because that only works if these things are not connected. In this chart, it looks like choice of transportation does depend a little bit on gender, and so we have to use the more complicated way. Okay, on to D. If a student is selected at random, determine the probability that they are female. Females are 575 out of our 1,200 students. Travels by bus. Now we don't care about gender, we're just looking at the bus total, which is 650 out of 1,200. Is female and travels by bus. Now we just care about this square here. 300 students who are female and take the bus, so that would be 300 out of 1,200. Identify the following events. The probability that a female student travels by bus, we just got that. That's kind of odd. That would be, I guess you could write it as female and bus. Maybe that's what they mean by identify the event. They're in the female row and the bus column. And the probability of it happening, as we found in the last item, is 300 over 1,200. A student who drives to school is male. Oh, you know what? I take back this last item. I think I understand what they mean now. They don't just want a student who's female and takes the bus. They want it to be a given. So, what I think they actually wanted here for female student traveling by bus is the probability, given that a student is female, that they take the bus. So we've got a student behind this screen. You can't see them, but we'll tell you for sure that it's a girl. What is the chance that she takes the bus? So to look that up, there are 575 girls that it could be. This is the given that it's female part. And out of those, how many are bus passengers? 300. That, I think, is what they want. The trouble with these examples is we don't have a solution to check against, but reading their minds, this is what I believe they meant. Given that it's a female student, what's the chance that they're on the bus? I think that because this one is phrased a little more clearly and says, okay, we have a student, they drive to school. What's the chance that they're male? So now looking at the car column, we have 375 students who drive to school. We're trying to find this. What is the probability, given that we have a student who takes a car to school, that they're male? We already found this in part C, but pretend you didn't notice that. So the number of students who drive is 375. And out of those students, just the car students, the number of males is 200. And are the events the student is female and the student travels by bus independent events? Explain. If they are independent events, here's our test. The probability of female and bus will equal the probability of femaleness times the probability of bus passengerhood. Okay? This equation only works if the events are independent. So let's see if it works here. The probability that you're female and take the bus is right here. It's 300 out of 1200. So that's our left-hand side. Equals. Now, the probability that you're female is 575 out of 1200 in this school. And the probability that you're a bus passenger overall is 650 out of 1200. Okay. Big scary numbers. I want my calculator. Okay. 575. Oops. 575 out of 1200 is the female chance times 650 divided by 1200 is the bus chance, and then let's see if the calculator can reduce that. Okay, 299 out of 1152. So we get 300 out of 1200 equals 299 out of 1152. We could reduce the left side, of course. Let's do a proper job of this at least once. 299 out of 1152. Yeah, that's right. Okay, these do not match, which is the math saying, nope. Remember back here when you assumed that these things were independent, you were wrong to do that. So, no, they are not independent. And we're not surprised to see that anyway. If you work out percentages for each of these things, as I've mentioned before, there's obviously some skew here where more than half of the bus passengers are males, more than half of the other category is females, and the car category is slightly different as well. So knowing the gender of a student kind of changes your expectations for how they travel.